To the bitter disappointment of my speech therapist wife, I do not have a very loud voice, so I'll be using the microphone. I'll talk a little bit about my current addiction hobby, which is the crack language. And Joe asked me to give a little bit more introduction than I put in my slides. Since people always get into these language wars, it's always good to ask yourself, why are you doing it? With the lament, why did you do this? So, as a little bit of a background, I really wanted to do computer science, and I ended up doing physics instead. So I made a detour into doing numerical analysis first as part of the Voyager group at JPL, but working at Caltech. Then I moved to the high energy physics department at Caltech and worked with CERN at the LHC, where we had one of the, what I think the original big data applications, where we had a detector that produced about a petabyte of data a year, which at the time we were building this in the late 90s, early 2000s, was really a lot of data. You know, people like Google probably have a lot more data than that now, but that was a really big data source that we had to deal with. So one of the things we did was to build a web portal or web service application platform using Python and Apache to do data transfer of the physics data sets from not only CERN but places like Fermilab in Chicago, Rutherford Appleton Lab in the UK, and there was one in Italy, can't remember its name. But the point was that we tried to put together a lot of things and to do a lot of data transfer. And even at that time, we had a lot of languages that we were using. And after that, I went to a microbiology or nanobiology lab where we do DNA and RNA folding sequence design. And there it was even worse, so we also had some web frameworks. We had a big analysis framework, so many jobs to clusters, and you know, we had Python, we had Ruby, we had C. Like Jason said, it's really a polyglot environment. I think I added up once how many languages I have used, and I think I have used something like 26, if I count them all. And you know, it ranges all the way from assembly, basic, Pascal, C, C++, Python, Ruby, Shell. I could go on and on. I put on there, I luckily managed to avoid C# and Java because I really don't see the need for a virtual machine, because it was a very good idea for a set-top box where you don't have memory protection, but in a modern OS where you have a little bit of separation between processes, you really don't need it, and it makes things more complex, especially in terms of memory. Not necessarily speed, but especially memory, which is luckily growing more important now that everything needs to be scaled down to fit onto phones or not use as much energy in a data center. So that was one of the reasons I started looking at a different language to maybe do more things in the same language than have more languages do this, to have to interoperate. And on the numerical analysis side, we tended to start with things in MATLAB. I remember one of my first projects in the biology lab was to take a piece of code that produced a 3D display of a DNA and RNA molecule, and I re-implemented the code in Python and it was 20 times faster, but it was still slow. And it turns out that you start with using languages, the interpreted languages, in a way that they're designed for short statements where most of the work is just passing parameters and passing loops onto the language backend, the runtime that's actually heavily optimized. But as time goes on, you tend to implement more and more functionality in the interpreted language, and it gets slower and slower, and especially for numerical analysis, where you have sometimes, especially if you're doing combinatorics for RNA and DNA, where you have to try a lot of different combinations of pairings between molecules, you end up with a lot of inner loops that you begin to implement in these languages, and then you suddenly have to either implement an extension in C, or you have to switch your whole code base to something that's compiled and faster, which is C, C++, C#, or Java, or not many people have actually used Fortran for a long time, so luckily not Fortran. But so there tends to be a bit of a divide between the interpreted languages and the compiled languages. And I was really looking for something that can bridge that gap. So once you move to the more common compiled languages, then you have a lot of boilerplate to deal with. You have to deal with makefiles, compiling things, and deploying things. Well, you do that for Python too. But it's a lot more cumbersome. I think everybody knows that. So that's my problem that I want to address, is that we are using too many languages with too much impedance between them, moving between them, and that they really reduce productivity in the long run. In the short run, you win by implementing things quickly in a script, and you lose time in the long run because you have to migrate and re-implement things in a different language, which takes a lot longer. So I started looking around for a language and a runtime that's compiled and statically typed, because I like it that the compiler checks up on the types that I use. In Ruby on Rails that I use all the time, I can't tell you how many times I'm trying to compare things and the one is a string and the other one's a number. So I like it that there's a compiler babysitting me. And it's extensible in the sense that I can interface to existing libraries, because I don't want to rewrite everything in the new language. If I want to talk to a Mongo database, I don't want to implement a new Mongo client. There are many, well, at least 2 C-based Mongo clients that I should be able to use. I looked at a lot of languages that I just didn't want to learn the syntax, like Eiffel or Lisp and a few others. I think Mercury comes to mind. If anybody's heard of that, that's also a LLVM compiled language. And I'm not great at tracking references, so I want a computer to do it for me. So I would like to do some form of memory management. And I have a list there of things that I looked at, and one of them is D, which is probably great, but it has a little bit of a fractured community. There's another one called OOC, which compiles into C++, Go, Hex. I don't know if anybody's heard of it. It's used a lot in game development in Flash. A lot of the games that you'd see on the web browser will be actually implemented in Hex and then translated into JavaScript. There's a great language called Object, which is written by one guy, and I think it's only used by one guy, which is quite an achievement. It's a great language with very big runtime, but I've never seen it used anywhere else, which is not so good. And the reason is that he implemented the just-in-time compiler on his own, so it's all from the ground up, one person, and it's an amazing achievement, but it seemed to me a little unsustainable. I don't know if anybody has heard of Vala. That is a sort of a C-like language that compiles into C that uses the G object system, the GNOME GTK object system, and of course Ada, which the military likes to use. I don't know if they still use it, but I do. I actually had a course in that in college, and it's a great language if you consider what they did in the late 70s and early 80s, what they achieved with that. It's better.
As long as you don't have to change between types.
That's also right. Yeah. So I also later found Rust and a language called DAO, which used to be spelled DAO. So what made this really possible is that the LLVM compiler infrastructure started getting more popular, and that allowed the separation between the actual language and the compilation and code generation steps, so that it became possible to implement your own language and not have to worry too much about the other two steps, which are really hard. The optimization and code generation is all handled by LLVM, and it's being, as you know, actively developed by Apple, which took over the project, and the Rust language from Mozilla uses that, and I had to put in there, Crack actually predates Rust, so when I was looking for it, Rust didn't exist, or they haven't made themselves known. And there should be some form of interoperability between these languages, and maybe there will be in future. I know Rust focuses a lot on parallel processing and thread management and message passing and continuations and coroutines and stuff, whereas Crack is not explicitly exposing that as a language feature. So there's my brilliant logo. So the idea of Crack is to provide a mashup between a scripting language and a compiled language, so that you can write the script in 3 or 4 lines, a throwaway script, and have it perform as would a compiled C or other native language. And just to characterize it a little bit, it derives concepts from C++, Java, Python, and it's object-oriented, it's strongly typed, and it allows things like the usual classes, modules, and operator overloading. And as I said, it uses the LLVM compiler infrastructure, which is getting better all the time, especially doing optimization and producing codes for different architectures. I was talking earlier about there's a project to port the language to the Raspberry Pi, which is an ARM-based architecture with quite a limited memory and CPU speed, for which this is ideal because it gives you the power of a small code base or small native binaries, but very quick development. At the moment, the compiler has just-in-time and ahead-of-time compilation. And by just-in-time, I mean when you run the script, all the code that it includes gets compiled right there, which takes a while. And currently, the biggest project going on is to work on cached just-in-time compilation the same way that Python does it. So when you run your Python script, if there are modules that you import those .pyo files of previously compiled Python code that it doesn't need to compile again. And I put there, it's a slightly non-PC name. A lot of people don't like the name crack because of the drug reference, but as the logo suggests, it's more like a revelation. So maybe that stick. I didn't pick the name. So just some formal contact information. If you want to look at what I'm talking about, the page is on Google Code. So just search for crack language. The person who started it is Michael Muller, who works at Google in New York. And there are usually 4 people on our IRC channel on Freenode, and all of them have committed code to the project. So if you use the language, you'll be very welcome. There's also a Google Plus page, and since I always look at the license of any project I look at before I use it, it's using the Mozilla public license, which is a very liberal file-oriented language. I don't know if anybody's familiar with licenses. This is different from the way that the GNU LGPL works, for example. It doesn't talk about the work. Every single source code file is copyrighted, and it may be changed, and it might be compiled and linked into whatever you want to. So it's very friendly towards proprietary code, as opposed to we were using the LGPL before, which made it almost compulsory that the library needed to be replaceable by something else. But that might be a little bit too arcane license detail. Anyway, you will like the license. It's very friendly, very liberal. So this is the part where people either get very riled up or their eyes glaze over. So I'll go through a few slides just showing what it looks like. And the idea is that obviously if you like it, you will use it. So it looks like a script. If you think of Python script, it will look almost the same. Comments uses a hash or a double / like C++, or even C like / comments. Modules contain symbols, and each file is a module, and each directory is one level up, higher level module. I will talk more about that later. So that's how you would write hello world to the standard output. And this is actually one of the most complex features of the language that I will talk about later, but this is not a string with backticks. It's actually an operator, much like the C++ double less than operator. But more about that later. So to run the script, you do like you would in Python, just crack and the file name, and it compiles the script, and it compiles all the standard libraries that you include every time you write that, and then executes the script. Or you can generate a native binary like you would C or a C++ file and execute the resulting binary. So like I said before, Crack is a strongly typed language, but it does have some very convenient type inference that it does. So most of the time you can get away with simply writing things assuming that the compiler will know what you're talking about. So the first statement there is just I equals or is defined as 10. or you can define its type as a 64-bit integer equals 10. Same with a floating point number, either implicitly or explicitly. And it has all the usual types that you want to use, bytes, 16, 32-bit, and 64-bit integers and unsigned integers. It currently only has 32-bit and 64-bit floats. It doesn't have 80-bit floats, which we actually use in work a lot, so I still need to write some code to have that work. And then it also has pointer types like a void pointer and byte pointer for strings. And then you can actually do pointer arithmetic with the int z and uint z type. So you can, for example, convert a byte array into uint z, and then you can add them and subtract them and divide them and go nuts, just like you would be able to do with C pointers.
So you have to specify the implicit or explicit typing with the colon equals modifier?
If you use colon equals, it's implicit. If you don't, then it's just like it would be in C.
Those last two are equivalent.
Those two are equivalent, except in the first case it's implicit. It tries to guess that by 10 you meant an int and not a float.
But why would you have to specify with a colon? Like, why doesn't it just understand that a variable declaration without a type would be an implicit declaration?
Well, it does. Maybe I don't understand.
Like if you like,
Is there a colon equals an E?
yeah, couldn't you just omit the colon?
The size of the statically type.
No, I understand, but couldn't you just say f equals 10.0 without the colon, and there's no modifier to f, so you know there's no type to f, so you know it's an implicit type.
Yeah, so the colon means define it. You can later say f equals 10 after it's been defined.
If you say f colon equals twice, the second time you're throwing your...
So in other words, you have to pre-declare variables. This is a pre-declare.
This is
That's
If you
right.
don't do a
Pre-declare,
pre-declare,
right.
it's going to say you don't have an
That
I.
That's
variable
right.
doesn't exist. Right.
That's right. Yeah, so it's really like most compiled languages. You need to pre-declare variables before you use them. And
F is an implicit definition,
that's right.
and then the next statement is a definition plus an initialization.
That's right.
Both of them are.
Well, the
A
other one,
definition and an initialization.
by initializing, you imply that it's declared. That's the difference. The second one, you don't need to say equals. The first one you had to, otherwise it wouldn't make any sense.
You're saying you can say float 64 f2 semicolon, and
Right.
it will create the storage
Right.
and not initialize it.
Right, and then F2 equals something else later on. Yeah, right.
Gotcha.
Whereas the first one, it lets you do that implicitly.
Yeah, so the convention that's used a lot, and I'll show it later, is colon means declare it, and declare it implicitly. There are also primitive arrays of all of the above, so you can have arrays of unsigned ints, and you can have arrays of pointers and all those things. And those primitive arrays are not memory managed, which you sometimes need. So the idea is that even though it gives you some added tools, you don't lose the low-level functionality that you would have with C or C++. So it addresses quite a wide range of application. So functions are also types, and you declare them the same way as you would in C. They have types in the function name and the arguments and a return value. There shouldn't be anything strange about that. The only interesting thing is that I would have a function argument in there. So any function can also be a variable, just like a class can be a variable. classes are declared the same way as they are in C++, but they are variables. So you can assign one to the other. You can pass it as a variable, and it has properties, and you can do other interesting things with them that I'll get to later. So as for looping, there's the usual for loop, and I'm adding a little bit of an argument to our cout statement. It allows you to put in variables, as would be very useful. That particular for loop just prints out all the command line arguments to the program. There are iterators, and there we see that colon again to declare a value that's going to be available to the rest of the loop. So this is, I think, like in JavaScript, you can do that. You can iterate through an array, and the argument value in that case is available to be printed out in the rest of the loop. Same with while, and there is no goto, which is actually in some cases it's necessary. I've found a few places where I need to use gotos. Classes, very simple, like C++. You declare them with their member variables. In this case, a convention is used to define which ones are private, which ones are public, and so on. A double underscore is private, single underscore is protected, and without one is public. So it just makes the syntax easier. I think Python does something like that with a double underscore, but I think you can still access it. The protection is not very strict. The constructor is an init operator, and most objects derive from a single object class, and all objects are reference counted. So when they're used in other places and there are references to them, they don't go away until the references go away. So that helps a lot with memory management. And if you do write classes that use non-memory managed objects like the primitive arrays, you do have to manage them yourself. But it also it gives you the power to shoot yourself in the foot if you want to, which is always useful. Operators can be overloaded just like they can be in C++. You can overload the square bracket operators, plus, double plus, plus equals, divide, all those things. The special operators are the constructor init, the destructor, and there's also a call operator. So you can make objects callable, make them into functors if you want to be really fancy.
There's special syntax for static.
Yes, I'll get to it, yeah. Oh, and I actually left out this bind and release are also operators. So when you release an object, the release operator method will be called. It supports generics using a square bracket instead of less than and greater than that C++ does. And it works exactly like you think it would. And you can have multiple types, and you can derive from other classes that are also generic. Like, for example, the array object is one that I use all the time. You can have an array of integers and floats and so on. I put in this line that there's actually, since we have a statically typed language, when we declare something, we usually have to add the type. So in this case, I'm declaring an array of floats, and there's special notation to show that it's an array of floats. You can't just, like in Python said, B equals 1, 2, 3. In this case, it won't implicitly assume that floats. And there's an annotation for methods that are static or final. Same as annotations in Python with the @ symbol.
So are there any concept of anonymous class?
Not at the moment, no. Also, abstract classes, so you can define interfaces. There are actually interfaces too, but they're a little bit older. We don't use them anymore, so you can declare an abstract class with abstract and concrete methods that derived class has to implement. So in your implementation, in this case, you have to implement the add method, and then the compiler will warn you if you don't have all your abstract methods implemented. The language is actually pretty flexible. It also allows you access to the compile time state of compiler, and one place where you can see it is that you have defines, like you have the hash defines in C or C++. You can define macros, which is a different way to do generics. You can define different methods with different type arguments. You don't have to retype it all the time. That's just a convenience. And I'm not going to say much more about the compiler state access, but you can actually implement little DSLs in the language so that they compile into code that you can write code that the compiler has access to at compile time. So you can really change the character of the language if you want to implement DSLs. There's exceptions with try catch clause, and they work exactly like you would think they do in Ruby or Java. They each have a message argument, and you instantiate them like you would call a function actually. And exceptions are classes too, so you can do anything with them as you can do with classes. So I'm going to say a little something about the backtick operator. So I/O is handled by formatter objects that take strings as arguments, but the backtick operator is like the C++ double less than operator. So if I have that string or that statement that says cout, a string and variable name, it is equivalent to the little piece of code at the bottom there that it calls the cout enter method, and then each of the arguments in succession, a string and then the name and then the /n and then the cout.leave method, and it gives you a string that a cout is actually a writer as well, so it writes the argument, which is a string. So that, to me, that's the strangest thing about the language, that you have this backtick operator that you have to get used to. But the point is that there are certain conventions that are used that make things easier, so you can easily implement your own formatter object. You just add an enter and leave and format method to it. Then you can use it with a backtick operator. In the same way, there's a protocol for iteration, and you can implement iterators very easily in your classes. So you can do a for-item colon in an array, so item gets declared, that's why the colon is used. Same with while. And then there's a sequence constant protocol, so that for arrays you can specify the square bracket with all the elements, and it's actually just calling the append method of your sequence object. So that's one of the things that the language tries to do, is to follow what Rails does and to use convention over specification. So you use the protocol, and you will always know that if you use the append protocol, your class has to have an append method. Modules is another sort of protocol, if you can see it that way. In this case, I'm importing from the directory io/readers the readers file and the line reader object from there. So in that case, it's the same as Python. Works exactly the same way. On a higher level, code is stored like in Java or Python or Ruby in hierarchical directories, and you can import them with an import statement with the dot in between the directory names. And as I said earlier, access control to objects is via conventions. So if you have objects with an underscore in the name, they will be protected, or double underscore, they will be private. And an important optimization is that second order imports are not allowed. So it helps quite a bit with debugging. You know, if you implement the line reader, it always comes from the same file. It doesn't go via another file which has a different version or has a different, modified it in some way. So what can you do with this? This is a great language. What can you actually do with it? So starting from bottom level, there are things like buffers and strings and exceptions. You can do I/O, open files, read lines from files. There are data structures like arrays and hash maps, ordered hash maps, and lists. And there's a numeric vector class, quite a few containers that you can use. There's some utilities to do command line parsing, logging, process forking, networking, sockets. There's a binding of the PCRE regular expression library. Is actually part of the regular runtime. There's some ASCII string utilities, XML and JSON, and INI file parsers. Some math hash functions, sorting, things like base64 encoding, random numbers, times, dates. I know Michael, the author, does a lot of things with synthesizers, so there's a good library for doing MIDI and also sound generation. And one thing that's really useful for me is that there's a very easy to use extension generator that you can wrap existing C libraries, that you basically write an interface definition that looks a lot like Crack, that compiles into C++ code, that gets compiled into a shared library that you can load as a module into your code. So there are a couple of bindings already that make things useful, like I mentioned, the regular expression library, libpng, SDL, Cairo. And since this is a MongoDB group, there's a MongoDB binding. I don't know if anybody's used Crossroads IO. That's a message pub/sub library. NetCDF is a popular scientific data format. libcurl, and also the sound library. So the story is, I started to look at Mongo and I joined this group. And Joe asked me, "So, do you want to present a talk?" And I said, "Well, sure." And I never knew it would actually happen. So, so what are some other people doing this? They're the author of the Qt smoke bindings. That's a very complete Python binding for the Qt libraries. Has been working on generating a crack binding as well, which I am very excited about because it allows you to build really nice Qt interfaces very quickly, like the script. Somebody made an interactive shell, so you can enter commands like you would do on the Python or IRB interactive shell. There's a Regal parser generator, so you can write parsers and have it produce cracked code, which is what I use to make JSON, BSON, and XTR parsers and do serialization in those formats, which is very useful when you're talking to a Mongo database, if you know JSON and BSON. I'm doing some stuff to make an SCGI web development program platform using all of the above. And I know Michael Muller is working on a port to the Raspberry Pi, which is ARM-based. And since at least 3 of those are what I do, I don't know if I missed any. The other people that do stuff didn't let me know then. So I hope I didn't bore you too much. We didn't actually have a language war, so most people have been quiet.
Wait till we get to the question.
Oh, okay, good. So there's a complete manual online. Most of the modules actually don't have very good documentation apart from the manual yet, because I've been lazy and I haven't written a documentation generator yet. At the moment, it really needs LLVM 3.3. I think the change was made just today from 3.2, and it needs to be on Linux. There's been somebody working on an OS X port, but I haven't heard from them for a while. So if somebody wants to do that, that would be great. And we haven't been very good at community building, so this is what I'm trying to do here. If you think this is useful, and you have too many languages that you are using, this is, like somebody said, this is not getting on the ground floor, this is getting on at the sub-basement. If you want to influence something, you can have a lot of freedom to do things the way you like them. Most of the modules that I mentioned, I went on IRC and I said, is this available yet? And they said, no, why didn't you write it? So I did, and so they had to accept my code. So I really like this, so I do all the development that I do. I use this simply because it does everything I want it to. It's fast and it's easy, and I can use it for little scripts, or I can use it for complete projects that compile to big, huge binaries or shared libraries. That's it.
So besides being able to put on your resume that you do crack,
I'm trying to keep it out of there.
I think you said one of the major advantages is that it's like C++ with memory management.
Yeah.
Okay, and that you can do it as script as well as compile.
That's right. Yeah. So
Any other key reasons that somebody's interested?
it's concise and it's very expressive in the sense that it produces very clean code that is very readable because everything is explicit, as opposed to a lot of the C++ style, I think, makes things sometimes a little hard to read and hard to know what's exactly meant by it.
Is that the code or is that the writer?
that too, yeah. So it forces you to be more explicit.
Is
Yeah.
anybody else in your team using it now?
No, I use it just for myself. If I did use it for work, I wouldn't tell them at the moment.
It's written in C?
It's written in C++.
C++?
Yeah.
So what kind of learning curve? I mean, is it a slow process?
No, I think it's much quicker to learn than it would be about the same as Python, I would say.
Do you need concurrency support in debugging language?
No, at the moment, not at all. So at the moment, you would have to use pthreads, I think.
So if you had to pick one feature so that you can tell all of the people using those other languages, wow, look at what I can do here. Not the judgment, oh, I love it, but
Sure.
feature. What is on all of the syntax is, wow, I couldn't do it with something else, or look how much better this is.
I think it allows you to build fast code fast.
So it's not the syntax, it's the environment.
Both. It has a very concise syntax, like using the protocols and conventions, as well as being a sort of a C-like syntax, makes it so that most people already know what the syntax would be. They know there'd be a curly brace. They know having a type, then an argument to a function, and it has a lot less boilerplate than other languages. It doesn't have include files, and everything is explicit. So if you, yeah, let's stop there.
What does it have that Go doesn't have?
It has better syntax.
Okay, well, I'm going to fight that one.
Yeah, that's really personal. I just didn't like the Go syntax.
So it needs LLVM in runtime?
Yeah.
You can't compile standalone native runtime?
It has its own runtime, but once it's compiled, it only uses the correct runtime. It doesn't use the LLVM runtime.
Oh, okay. So, but you do have to have the correct package at some point. Yeah.
That's right. If you compile binaries, then it only needs some shared libraries from Crack itself. It doesn't need the LLVM environment.
Okay, got it. Yeah. Just needs the standard library.
Yeah.
Monty.
So when you're doing Python, I assume you use NumPy.
Yeah, that's right.
So does this meet a lot of those scientific compute requirements?
For me, it does, because that's why I wanted to use it, was for scientific computing. I haven't written a lot of the scientific handling code, like arrays. They're only one-dimensional and 2- and 3-dimensional arrays, but you don't have all the linear optimization, array inner and cross products, and all those things are not in the library yet. In the back there.
In regards to like in the past, the board trains and then the math class, do you find this more in are you in a community that would be mathematically and scientific community that would be more catered toward, or is it open to all?
Oh, it's open. I think because of the libraries and because the way I use it, there's a lot of things that you can use for web backend development, because there's the JSON and the Mongo interfaces, and the curl binding to do web requests with if you have a REST interface. So I mean, it's a language with a runtime, and because the runtime is still small, it can be used for anything.